Applications break down when developers build coupled systems where user interface rendering and business logic are intertwined. When an engineer updates the color of a button or the layout of a screen, they shouldn't trigger a failure in the underlying code. But in a coupled system, changing a simple visual element can accidentally sever a critical data pipeline. To build stable software, we have to enforce a strict boundary. User interface code and application logic cannot mix. The user interface has exactly one mandate. It is a passive surface that exists only to display data. It is restricted from heavy lifting. The UI does not compute logic. It never fetches external network data and never mutates the application state. Enforcing this requires a structural solution, a unit-directional delegation pipeline. Routing data through rigid checkpoints creates a barrier preventing the UI from bypassing logic. This stack relies on 6 layers, built bottom-up: database, repository, use case, view model, activity, and composable. To see exactly how this architecture protects an application, we are going to reverse engineer it. We will build this stack upwards from the bedrock of raw data all the way to the final pixels. Establishing these 6 boundaries provides a stable framework for protecting an application against long-term architectural decay. Every application begins at the foundation, where raw information is permanently stored. This is the database. Its single responsibility is mechanical persistence. It writes raw data to disk and retrieves it when asked. Allowing the upper layers of an application to query the database directly creates a vulnerability. It forces the application to rely on the specific syntax of local storage technologies. To shield the application from these direct data connections, we add a buffer layer. This is the repository. It acts as the mediator and the single source of truth for all application data. It abstracts away the origin of information. When the app needs data, it decides whether to fetch locally from the database or externally from a network API, merging the result into one clean output. By enforcing this boundary, any layer sitting above the repository remains blind to the mechanics of how data is fetched or stored. Together, the database and the repository form an isolated data layer, encapsulating persistence mechanics away from the application's business rules. Once the raw data is successfully retrieved from the bedrock, the application has to apply rules and calculations to it. We introduce a dedicated component strictly designed to hold these calculations. This is the use case. It operates as an exclusive quarantine zone for the app logic. A use case is constrained to represent exactly one single, highly specific business action or user intent. In operation, the use case executes a precise sequence. First, it reaches downward, requesting the necessary raw data from the repository. Second, it applies the core business rules, algorithms, or validations to that raw information, transforming it into a refined output. This isolation offers defensive value. If a company updates its calculation policy, engineers only need to edit that specific use case, ignoring the UI and the database. The use case serves as a strict architectural firewall. It ensures that the core business logic remains locked in the middle of the stack, unable to accidentally leak upward into the presentation elements. With the logic processed, the final challenge is preparing that refined data for visual rendering, without forcing the user interface to do any computational work. We add a state manager component to bridge the gap. This is the view model. Its responsibility is catching the logical output from the use case and holding it in active memory as a defined UI state. Holding state here is intentional. If a user rotates their phone screen, visual elements are destroyed and recreated. Because the view model sits safely below the surface, the data survives these events intact. This brings us to the top of the stack, where the final 2 presentation components reside. The activity acts as the structural container. It is the system-level entry point that hosts the user interface on the operating system. Nestled within the activity container is the composable. This is the pure execution of the UI layer's primary mandate, responsible for drawing the final pixels on the screen. The relationship between these layers is one way. The composable strictly observes the view model. The composable does not run logic. It reacts to whatever state the view model holds and repaints the screen to match. By assigning memory to the ViewModel and restricting the composable to a passive observer, the UI layer achieves the separation required by the architecture. The architecture stack is complete. Looking at the full structure, a distinct vertical distance separates the foundational data from the surface pixels. To see this separation in practice, we can initiate a simulated stress test by triggering an update at the foundational level. As the data hits the repository, its origin is abstracted away, standardizing the information for the rest of the app. The payload travels up into the use case, triggering the required business calculations and algorithms. The processed result enters the ViewModel, where the application's overall state is updated in memory. Finally, the composable reacts to the new state and renders the correct visuals, without touching a single line of logic. The structural separation is evident. By placing 4 distinct layers between the raw logic and the final pixels, we've created a buffer that prevents accidental logic leakage into the UI. This unidirectional data flow simplifies quality control. Testing an application becomes a predictable process, as engineers can isolate and test each layer independently. It also allows teams to scale development. Thanks to established boundaries, interface designers and logic engineers can work simultaneously without breaking each other's code. Maintaining this specific 6-tier pipeline effectively honors the architectural mandate. UI code exists mainly to display data, while the logic remains safely locked below.